Hey friends, today we're going to work on the smart contract development of the NFT marketplace. Solidity is a programming language we'll use for developing smart contracts on the Ethereum blockchain. It is a primary language used for creating smart contracts on the Ethereum blockchain, and the smart contracts are becoming more popular because they offer transparency, security, and efficiency, which are some of the benefits of the blockchain. So in this lesson, you'll have a crash course on Solidity, understand blockchain basics, which you can also find in my Instagram profile, and develop our NFT smart contract. This lesson is entirely beginner friendly. So let's go ahead and build and deploy our NFT smart contract. Don't forget to like, comment, and subscribe. Let's begin. So we'll create a new folder called NFT Marketplace. Wait, let's navigate to it. Then we are going to go ahead and create a new node application using the command npm init. Head over to nodejs.org where you can download the Node.js and install it in your machine so that you can be able to proceed to creating the node application. Our package name will be NFT Marketplace version 1.00. It's a smart contract for an NFT marketplace. Endpoint will be index.js. Test command, we can use chai, git repository, keywords NFT, author Mobtress Studio. Yes. Once that is done, our application is created and we'll have one file in our folder called package.json. The package.json holds important information about a project. It contains human-readable metadata about the project, like the project name and description, as well as functional metadata like the package version number and a list of dependencies required in the application. Next, we will install Hardhat. Hardhat is a development environment that helps developers in testing, compiling, deploying, and debugging the apps or smart contracts on the Ethereum blockchain. To do that, let's run the command npx hardhat init. So next, let's select create. We have different options. You can either create a JavaScript project, create a TypeScript project, or create an empty hardhat.config.js. If you're familiar with TypeScript, you can actually select create a TypeScript project and just walk along with us during the tutorial, converting whatever we're writing on JavaScript to TypeScript. But as we're going to select create a JavaScript project. Let's add a .gitignore. So do you want to install this sample project's dependencies with npm? Say yes, because it's a dependency that we need, which is called the Nomic Foundation Hardhat Toolbox. This plugin is a bundle of commonly used packages and Hardhat plugins that is required to start developing with Hardhat, so it's necessary for you to install it in the node application. Our project is now created. Once it's complete, you'll find more. We have now more folders and files created in our node application, which is cool. So the initial project looks like this. This is how the structure looks like. There's a contracts folder, there's a node modules, there's a scripts folder, there's a test folder, and there's .gitignore, hardhat config.js, and all. The contracts folder is where the source files for your contract should be, or this is where we'll come and code. In short, we'll remove this pre-existing file that has been created and create our own smart contract. Then the node modules is what contains the pre-generated and generated plugins that we are using in our application. Then we have the scripts folder where simple automation scripts will go. For example, this deploy.js, which will deploy our smart contract to the testnet in our case. Next, we have the .git ignore, which basically ensures that certain files are not tracked by Git, and the Hardhat config, which is the configuration file for Hardhat. All right, so next we will install OpenZeppelin. OpenZeppelin is a leading open source framework for building secure and decentralized application that is smart contracts on Ethereum and other blockchain platforms. It provides a set of standardized and audited smart contracts. These smart contracts have been thoroughly tested and audited by security experts to ensure they are secure and free of vulnerabilities. This allows us developers to inherit them and build on top of the framework, which is much easier than coding from scratch. npm install OpenZeppelin contracts. Okay, that's done. So with that completed, we have now set our environment and it's ready. And now the next thing is now heading into starting to code our smart contract. So now let's start our development. We'll head over to the contracts folder. In the contracts folder, we'll delete the pre-existing file, move to trash, and then we'll create our own file called NFT marketplace.sol, which is the extension for Solidity file. So here we are. First things first, in a Solidity file, we always start with defining the license. That's the first line of any Solidity file, specifying the license that you want to use. SPDX means Software Package Data Exchange. SPDX identifiers are basically used to communicate your source code's licenses using the comment delimiter. The work of it is to make it easier for your code to be reusable, knowing which license the code is complying with. So there are different types of licenses, for example, MIT license, the unlicensed, and what you add to the code is its short identifier, which in our case, the unlicensed, the short identifier is unlicensed and unlicensed. And for example, for a license like MIT license, the short identifier is MIT. So what we're adding is the short identifier. To learn more, head over to spdx.org stroke licenses and you'll learn more about it. So to do that, it comes with a comment delimiter. So we just set it as spdx license identifier. For in our case, we'll set it as unlicensed. There are different types of licenses. In our case, we'll set as unlicensed. Next thing, we're going to define the Solidity version that we're using by using the pragma keyword. The pragma keyword is used to enable certain compiler features or checks. So the pragma directive we are using is a version pragma, which specifies the compiler version that we're going to use. So we'll set pragma solidity is 0.8.9. Next thing now is where we define or we create our contract. To create a contract, you use the word keyword contract, which is similar to class in other languages, and then we give the name of our contract, which will be NFT marketplace. It's ideally, or it's recommended for you to name the contract to be the same as the name of the file. So ours will be NFT marketplace. Great. So we have created our first contract with the name NFT marketplace. Inside here is where a lot will happen, and we're going to go step by step. So before we do anything, we are going to first install. If you recall, in the previous video, we talked about the standard that is used to create an NFT smart contract, which is ERC721 standard. And in our case, we're using a subscription model, which is ERC5643. But what happens is we are going to inherit or inherit the ERC721 interface. And then what happens is that the ERC5643 is an extension. We'll just add these other functions and events that are an addition to the ERC721. So for us to do that, we'll use the OpenZeppelin library. That's why we installed it. So we're going to import OpenZeppelin, contracts token ERC721 ERC721.sol. Great. And then once you do this, how you inherit in Solidity is by using the keyword is, and then just entering ERC721. But now there's a catch here. Okay, this error is because of something else, but you'll notice as we go on, we're not going to be using ERC721, but we're going to be using the ERC721 URI storage, and I'll explain that as we go ahead. But for now, let's just set it to ERC721, and you're going to see us updating this as we go. So what it's asking for is a constructor. A constructor function is executed upon the creation of a contract. You can use it to run contract initialization code, and it also can have parameters, and it's especially useful when you don't know certain initialization values before the deployment of the contract. That's where you can set your things. And the constructor in this case defines the token name and the symbol. The string should be quoted with double quotes instead of single quotes. That's very necessary. And you declare the construct using the construct keyword. Set it ERC721. And this constructor requires two things: the name and the symbol. The name of our NFT and the symbol of our NFT. So in our case, we can say, let's call it NFT magazine subscription, because that's what we are actually creating. And then we can name our symbol as mag, meaning magazine. Symbol just refers to, like, for example, Ethereum, the symbol is ETH. For Bitcoin, it's BTC. So in NFT, you can actually define your own symbol to define your NFTs. Yeah, so after that, we are done. We have now our constructor, we have our contract, and this is now like the skeleton or the foundation of where everything will be in. This is the main skeleton, and I hope you have understood simply this. Next, now let's start creating our functions, our events, and along the way, as I promised, we're also going to have like a crash course on Solidity. So I'll be explaining in detail certain things that we'll be adding. So for our contract to grow, we'll start creating our functions, and I'll be mentioning the functions that will be needed in our NFT marketplace, and then now we're going to be designing it in form of code. Let's create our first function that represents the first feature, which is creating an NFT. So under here, there are two ways of doing it. We can just create the function straight away, or we can first define what our function is all about. To do that, we're going to first say use the NatSpec. NatSpec comments are special comments that provide rich documentation for functions, return variables, and more. They are used directly above function declarations or even statements. So we're going to add a few comments here. So at dev, when we want to define this function, what it's doing is that this function means received NFTs. Great. And then we need to specify which parameters do we need. So our first param will be the token URI, which is the new token URI for the magazine cover in our case. So once that image is created, it's going to be uploaded to IPFS. The IPFS storage that we'll use is Pinata. And then once it's stored, we're going to receive a seed ID, or more or less like a URI that links to that image, and that's what we're going to use to store in our smart contract. So we need that token URI. Next parameter that we need is the title. We'll need to ask for the title. When you're creating the magazine, we need the image. We ask for the title, which refers to the name of the magazine cover that you're creating. It could be, for example, fashion, football, or sports. Next thing will be, and the last param will be description, where you provide the detailed information on the magazine NFT. Great. So the last thing, what are we expecting to return? So with the moment we create this NFT, we want to receive or return back the token ID, because that token ID is what will help us to, if we need to get more information, or if we need to do other transactions, we'll be passing that token ID and not all this information. That's what defines the NFT that has been created. So in terms of return, what we need to be returned is a token ID of the created NFT. Great. So with that information, it helps you, even if you want to pause this video right now and try and create the function by yourself, and then come back. With this information, this is enough information to help you try something out. But we can proceed by creating our first function. And to define a function, use a function keyword. The function keyword followed by a unique name. Functions should use mixed case. So as the arguments themselves, they should use mixed case, and specify the parameter types and names. A common convention to use is an underscore as a prefix for the parameter names to distinguish them from the state variables. We'll give it the name create NFT. In Solidity, you'll find that a function, you cannot just create a function without anything. It always requires some form of modifier, either if it's in terms of visibility or if it is in terms of overriding or immutability. It depends. In Solidity, their modifiers are grouped in different types. There is visibility, which refers to public or private. Public means it's accessible outside the smart contract, and private means it's not accessible outside the smart contract. There is mutability, which refers to the view and pure modifier, which prevents any changes from happening to the state. There's also the virtual, and also there's override, and also there is custom modifiers, where you can define or design your own type of modifier and inject it into your function. So in short, it's good to consider that there are two types of Solidity functions. There are those functions that modify the state of the blockchain, and there are those that don't modify the state of the blockchain, and you'll mainly find them marked with view or the pure modifier. So for our function, we're going to add public because we want to interact with it in the front end side, right? And then we're going to come here, and next thing we're going to pass the arguments as we mentioned here. So our first argument will be token URI, which will be in form of a string. And we're going to use a data location as memory. So for data locations, let's talk about data locations. The values of variables in Solidity can be stored in different data locations, and there are three: memory, storage, and call data. Variables of the value types store an independent copy of a value, while variables of the reference type like arrays, struct, mapping, which we'll interact with as we go on, only store the location reference of the value. So if we use a reference type in a function, we have to specify in which data location their values are stored, and we're referring to mainly the reference types of array, struct, and mapping. The price for execution of the function is influenced by the data location. Creating copies from the reference types costs gas. Okay, so values stored in storage are stored permanently on the blockchain. Now, if you're using the data location called storage, if you use it on your variable, the value is stored permanently on the blockchain, and they are they're very expensive to use. State variables are always stored in storage, so you find even how we handle the state variables within the contract is very important. It determines how much gas we'll use. But values stored in memory are only stored temporarily and are not on the blockchain. They only exist during the execution of an external function and are discarded afterwards. They are cheaper to use than values stored in storage, which you'll see. So functions, and you'll find that for function parameters, they need to have the data location, either memory or call data. So someone might be thinking, so is it obvious that I would actually go for memory instead of storage because of gas? It will depend. It will depend with the type of function and you're working on. It's not just obvious that you'll have to go with memory because it uses less gas. There are certain variables that will need to be stored permanently, and you'll find it mostly in state variables. So we give it the data type of string, data location of memory, and give it the name token URI. Let's do the same for the rest. And lastly, great. So now we have our arguments, we have received them. So what do we do next? So we're going to use a certain library called counter. So the idea is this: we want to be able to handle the NFTs that we are creating. As much as they're being created, we want to create them by assigning them a certain as giving it a counter. For example, if by default the counter that we're going to use starts with 0, so when we create, our first NFT will be linked to the counter 1. The next one will be 2. It's an easier way to also even know the number of NFTs that are in your smart contract. There are many ways of doing this, but we're going to use OpenZeppelin to help us implement that. So we're going to add at OpenZeppelin contracts token utils counters dot sol. So I hope you're seeing the beauty of using OpenZeppelin. The fact that you're able to, because there's a lot that you have to do from scratch if you don't use OpenZeppelin, which is still okay. But if you want to like have an easier time creating your smart contracts, OpenZeppelin has done the hard stuff and followed the standards of Ethereum, which has been approved by Ethereum themselves. So it's just a matter of inheriting and just using whatever that they have and making your life easier. So next thing, now that we have the counters, we're going to define the counter variable that we're going to use. To do that, first we state that we're using counters, which is a utility that will always increment from starting from default to 0. So using counters for counters dot counter. So it's a way of including it into the application, into the smart contract. Now once that is done, let's define our variable, which will be a state variable, and again it will be private. This is something that we're using within the smart contract. We're not going to be exposing it, so it will be private. And then we're going to be defining state variables that we're going to use to store. So the state will always be saved. For example, if you create an NFT and the token or the variable is equal to 2, when the next NFT is being created, the state has already been saved to 2. So the next one will be incremented, and that will be 2 plus 1, and that means a new NFT will be linked to the counter 3. So that's why it's on the state variable, so the state is always saved. So let's define our counters.counter, and set it as private, and define ours as token IDs. Great. So we have our token IDs, and in this, if you want to learn more about the counters, you can always go to the file itself. It is detailed and also has very nice NatSpec comments. So you'll find that the counter now at this token's ID currently by default is equals to 0. So when we come to our function here, we're going to first take the token IDs and increment it. So that we start with 1, right? So we'll increment it. Then once we have incremented, now our token IDs is equals to 1. So we want to pick that value. So we define a new variable, a local variable called new token ID, and get the current token ID, which should be 1. Token IDs dot current. Great. So now that we have this, we want to we have our token URI, you have our title, we have our description. So what we want to do is a process that we hear a lot whenever we hear about NFTs, and it's called minting. We want to mint this NFT, and we don't need to do a lot of code, as I said again, because OpenZeppelin has done the hardest part. So all we just need to do, since we have already inherited it, we have already imported it, we just call the function mint. It has a function called mint, which sets the ownership of this new token ID that we've created to the owner or to the msg.sender. Great. So what for us to do that, we'll say dot mint, and as you can see, it has already set for us default. It's expecting a true and a token ID, right? So for us to do that, true means we're referring to msg.sender, or the person who is actually interacting with this smart contract whenever we're executing this function. And of course, when you're interacting with a smart contract or a smart contract, you're interacting with it when with an Ethereum address, for example. So this is what will be here. And then the token ID will be this new token ID. So that's what minting is all about. It's where now you're linking the we're linking stuff. Now we're linking the new token ID with msg.sender, and then we're going to make sure that we set the token URI to the token ID, this token ID. That's how they all link together. So we'll use another function called set token URI, which we are also importing, and then it will require the new token ID and the token URI. Great. Set oh yeah, now you see set token URI is used by the ERC721 URI storage. That's why I mentioned that, yes, when we were creating the basic, I wanted to show you how the skeleton of creating a contract looks like. You inherit the ERC721, but now we need the ERC721 URI storage because of how we are actually storing our token URI. If we wanted, there is another way of doing it, which I won't explain here right now, but with the way that we're using it, we'll need the ERC721 URI storage. Just a minute. Then now we're going to import it. So it's an extension of the ERC721. Contracts token ERC721 extensions. That's all. Great. So as you can see, our error has gone because now we have imported it, and this is what we're going to use, and the set token URI is found over here. So what we have done in terms of the minting function, we have linked the msg.sender to the new token ID that we have we've created, right? And then when setting the token URI, we have linked now the token URI to the token ID. So they're all linked together in some way. Great. So next thing we're going to do is we're going to set, after doing this, it's great. So we want to create a more of a, how do we call it? We want to store what these NFTs that we're creating within our smart contract. The thing is, if we decide to create a function where we are always getting the NFTs, that will consume a lot of gas. And if we can just like have a storage where whenever we have minted or created this NFT, we just store it somewhere within the smart contract where we can just pick or just check or just interact with it, right? So for us to do that, we're going to come over here and create another state, a state variable. And before we do that, our state variable will be a mapping. So what we're going to do is we're going to create a mapping, which will be a state variable. So the state will always be saved. Whenever I create an NFT, it's stored there and it will be retained over there. So we'll use mapping uint 256. And we want to, so this uint 256 will be holding the token ID, but we also want it now, the token ID will be linked to the information of the NFT, which is now the title, the more of like the seller or the person who owns the NFT, the token ID, the owner. There's a difference between seller and owner that will be interchanged within the smart contract. I'll explain later. We can also set the price. Initially it will be 0 until now the owner decides to now sell. We'll also have other factors like the title, as I said, the description. We'll also have like subscribers, likes, things that are actually managing that specific NFT. You'll find like things like subscribers, those are more on, you'll find them in the front end, and it's a nice way to actually allow users to interact and also gather more information about an NFT. So those are some of the things we'll just add. So for us to have that, or have that type of object that will be held, that will be linked to every token ID, we need another object here, and that object will define it to the data type of struct and give it the name NFT struct, and give it all those variables I have mentioned, starting with the token ID, address, another address that will hold the owner, hold the price. This address will be form of an array, so it's an array of data type address that will hold number of addresses that represent subscribers, and then we'll have uint 256 that represents the number of likes of that specific NFT, the title, and the description. Great. Now this is what we add over here, and then we'll continue to define our mapping. So we'll set it to private. You'll notice also when you're creating variables, you need to like specify these modifiers a lot. It's very, in Solidity, this is quite strict. It's not only in functions but also in variables. So we'll set it to private because we're just using it within the smart contract. It doesn't need to be exposed outside, and set it as NFTs. Great. So now that we have our NFTs, after doing all this, I want to create a simple function that will now set for us this store for us these NFTs that are coming in. So how will that function look like? So this is how it's going to look like. In simple, it will be quite simple. So it will be function. So we are setting the NFT. So there is the function. First things, a few things that we need will be passing, which is the uint 256 token ID, string, memory, title, string, memory, description. And then let's define give modifiers to our function. It will be private. This doesn't need to be public. So inside here, we're going to use now our NFTs, set our NFTs. Great. Before we do that, we've already minted and linked everything. There's we're going to come and set NFT is whatever we had created, link it to the token ID. This is how now we're going to define every variable that's in the NFT struct. So NFTs holding the key token ID is equals to dot token ID is equals to that. So let's do that for all of them. NFTs, sorry, dot seller payable msg dot sender NFTs dot owner is equals to payable msg dot sender. So in this state, whenever you're creating the NFT, we are both the seller and the owner. Or when I mean we, it's the person who's actually executing it from the front end with their address. They're both, when they're creating that NFT, they're both the seller and the owner in the smart contract. That's how it's been saved or stored as. Then we have the price, which we'll set to 0 for now. And then NFTs, we have subscribers, which will just add self as a subscriber, as a first subscriber. Then we have likes, we'll set it to 1. So we add our own like, almost similar to either Quora or Reddit. They do such a thing. And next thing, once we've done that, now we need to create a certain event that will be triggered. And that, what that means is that so whenever you want to store these things in this transaction logs in the blockchain, you need to create an event, and then we emit it so that it's actually stored in the blockchain. You're able to see like such, whenever you go to transaction logs in the blockchain, you're able to see such these events and be able to see what has been outputted. So simply put, we're going to come here and create an event. We create this event. We want to call it NFT struct created, to mean that it's just having a log that says that this NFT has been created and has these types of parameters: the token ID, the seller, the owner, the price, and all. So I could just pick this, or better yet, let me just enter it. Let me just copy, save time. Then it will be in form of a, place the semicolons with a comma. And the index this one, set it to unique. Great. So now that we have this, we want, when we create this NFT, when we come here and set this NFT in our in our state variable, we want to emit this event and show what has actually been stored. So we use the emit feature and just use the same name, because we're emitting this event, and then pass all those values. So we'll start with token ID, msg.sender, 0 NFTs token ID subscribers likes title and description. We are done. So now that we're done here, the reason why we have an error here is in our not-spec comment, we mentioned that we are having a return type, which we are. So we just wanted to finish this, be able to store this information of this NFT that has been created over here. Now we're going to pass this function set NFT and pass the token ID we're going to pass the title and description. Then I'll just pick this and put it at the top here. So once that is done, we do a return. But before we do a return, we need to specify a modifier for return called returns and specify the data type that we are actually returning, which is a uint 256, which is this. And then now we can return our token, our new token ID. Oops. Great. Let's copy this correctly and see valid implicit conversion from address. Great. So as you can see, I've just formatted the document. So we're finished with our first function, which is creating an NFT. So to just go through it again in just a second, we created here's the information about our NFT. We have called it create NFT, and we're passing the token URI, title, description, and we need to return the new token ID that has been linked to the msg.sender and the token URI. That's what we need to return to the user at the front. So we have done that. So we have just incremented, used counters, done received a new token ID, and we have minted it. We have set the token URI, and also we have stored this information of this NFT in the state variable for ourselves so that you can be able to interact with it rather than creating a function that will go to the blockchain and collect that information. So which will require an amount of gas. So just to avoid that, we're just storing it somewhere, storing it in a state variable which you can interact with it whenever we're using the smart contract. So that's what this second function is all about. And then we have returned our new token ID. So simply, I hope that makes sense. And I hope it wasn't that long. So in the next one, we're going to focus on the next function, which represents the next feature. Okay, let's focus on the next function. Let's create the sell NFT function, but in our case, it's more of sell subscription. Remember, we are working on an NFT marketplace by using the subscription model. So ours will be sell subscription. So we have created a magazine we have created a magazine NFT, and now you want to, as an owner of that magazine NFT, you want to sell a form of subscription so that whenever somebody buys it, they're able to access articles of the magazine and all that. So access the magazine itself, in short. So let's create that function. So what do we need in this function? So as a dev, we are selling a magazine subscription to the public. So what we're doing is that the moment you create an NFT, it will be just in your tab as your NFT. But now when we want to sell the subscription, so that it's now visible in the NFT marketplace, so that it's accessible to other people and they're able to buy, right? So we're selling a magazine subscription to the public, so it should be so that it's visible to the NFT marketplace. Because initially when you create an NFT, it doesn't mean you're selling, you've already sold it or you've put it on sale. You create an NFT, then now you place it on sale, right? The next thing is the params. Which params do we need? In terms of params, we just need two. We need the token ID. If you remember now, this is the token ID of your magazine. So instead of passing the information, the whole information about the NFT, that your NFT, we're not just going to use the identifier, which is the token ID, which we received when we were creating the NFT, right? So this is the token ID of the NFT magazine or your NFT magazine. Next, we're going to add the price, which is the price, param, which is the price, first to the price for the magazine subscription. Great. Lastly, so what do we want in terms of what can we return? In terms of return, we can return the total number of available NFT subscriptions. Okay, so now let's create a function and name it sell subscription. Please also observe the naming, how we're naming stuff here. There's a standard in which we should name. I really try to make sure that I follow them, but wherever I may have missed out, I'll correct it later. So first things, we have our function sell subscription, and as usual, a function in Solidity cannot just remain like that. You need to add some modifiers and also arguments. So for our modifier, we'll just set it as public first, and then our sell subscription, we're going to pass two arguments, uint256 token ID and uint256 price. Great. So we have that, and then we need to return. So before we return, now let's use this argument. First things first, we need to assert, because for us to this function, the person who should be able to execute this function easily is someone who owns this token ID, right? So we need to first check if they own it. They need to be the owners of that token ID. So we'll use an inbuilt function that's already available and pass, it's called is approved or owner, and pass the MSG sender, the person who is executing this request, and also pass the token ID to. Then that function will check whether this address is linked to the specific token ID. It should. If it's not, you should return an error. Only NFT owner, only NFT owner can perform this. Right? Great. So we need to check that first, so that we don't just set it in a way that the fact that it's public, it's already a risk. So if we didn't add this, that means anyone would have just come, set a token ID and a price and just set it to sell. But what we're doing is making sure that the person who's actually executing this, the token ID that they are passing, it's actually theirs. Great. So next thing we're going to do is first we remember the struct that we created, the mapping that we created, NFTs. We want to come here first and update. Using this token ID, we are updating the price now. So the price will be the new, but before we do that, let's first perform the transfer, because selling subscription in now NFT world, what it means in the backend is that we are transferring our NFT ownership from ourselves to now the smart contract. So that's how we are doing it in the smart contract. So first, let's transfer that token ID to the smart contract, so that now it's the ownership is for the smart contract. So we're selling it, right? And then after we have done that, we're going to update our mapping that's at the top. To do that, we need to pass transfer. It's also an inbuilt function, and it requires a from and a to and the token ID. You see the beauty of using the library like OpenZeppelin. So from, it's from us, the msg.sender, the person who is executing this contract, and then it goes to the smart contract, address this, and we are passing this specific token ID. So that's the brief. In short, that's the process of selling subscription. So in an ordinary NFT use case, not the one that we're using the subscription model, if it was just basic selling an NFT, with this function, it will have changed the ownership from, for example, from me to someone else, or to you who has actually bought it. It will okay, this is actually selling. I think I'm confusing with buy. So what happens is when you're selling subscription, we're transferring it from the ownership. We remove the ownership from ourselves and set it to the smart contract. So at the moment somebody decides to buy, the ownership changes from the smart contract, or from the smart contract to now that other person. So when you're selling, you're actually selling off your ownership. Great. So once that function is complete, we want to update our mapping now, because now that has been successful. We need to update our mapping in terms of the price, because now the price has been set. So we come here and say dot price is equals to price. So that's a new price of this NFT. And the next thing we're going to do is also set the seller. The seller is still the same, msg.sender, but the owner has changed. It's now address this. Great. Is there anything else? Great. So that's done. That's complete. So the last thing we have is now to return the total number of available NFT subscription. But right now we can't do that because we haven't been handling the number of NFT subscriptions that are available. Available means that it's available on the NFT marketplace. Somebody has actually placed a sale, and now that means these are NFTs that are on sale that somebody can actually buy. We haven't handled that, so let's handle that. We're going to use the counters library. So we just say counter and set it private as well, because we're just managing it within, and set it to NFTs available for sale. Wait, then we come here. Initially, any counter that's created, the default is 0. So we'll come here and set and increment it. Sorry. And increment it. It's a function. And then we do our return. So our return expects a total. That means it expects us to return a uint. So we'll come here, returns uint 256. And then we come here and do a return NFTs available for sale .current, which should be 1. Great. So basically that's the function of sell subscription. We already have an inbuilt function that is doing the transfer of ownership. That's what has made it much easier. And it's now moving from msg.sender, which is the address where the contract is being called from, and going to the address this, which refers to the address of the instance of this contract. And now that we have done that with just this one line of code, we have also saved our mapping, our state variable. We have updated our states so that we have the latest information when we continue to interact with our state variables, and we are returning the total number of NFTs that are available for sale, which is 1. So let's see you on the next function. Great, let's now focus on the next function, which is buy subscription. So then in terms of requirements, we need to buy a magazine subscription from the marketplace. Great. So the param we need to pass is the token ID, which represents the token ID of the NFT magazine. Then lastly, we do a simple return of true. Great, so we'll create our function, call it by subscription. We'll set it as public because we need to access it, and then we pass our token ID. Great. So once we are here you can just set this returns once. We'll just pass it as true. But now let's get inside here. So in terms of buy subscription, there are a few things that we're going to do. We need to check when the person is buying, are they sending the amount or the price of that NFT? Right? So we need to first get the price of this NFT. And as you can see, this is why we wanted to have a state variable within the smart contract, rather than having to create a function that goes and picks information about this specific token ID. So we're just picking it from our mapping, and we just say in NFTs, set the token ID and get the price. So this is a price. So we need to assert and check if whatever the buyer is setting as msg.value is equals to price. If it's not, we just tell them please send the asking price in order to complete the purchase. Right? Great. only when they send that. So we're getting this msg.value because we haven't added another modifier called payable, because it's this transaction is involves a transaction of funds. When it involves a transaction of funds, your function needs to hold the modifier payable. So once that is done, if the buyer actually sets the correct price, next thing we do is do the transaction. We can set the transaction from payable owner so we can set the payable who was the seller. We need to pick up the seller. So NFTs token ID dot the seller. We need to transfer this amount to them. MSG dot value. So it's going to send this the ether or the price of the NFT to the seller. Once that is done, we can now change the ownership. Sorry, it's supposed to be the other transfer. We can now transfer the ownership. To transfer the ownership now is when we use the other transfer, which is with the underscore. So we're transferring it from address this to msg dot sender. The person who is actually executing this transaction. Token ID. So remember, msg.sender is based on the person who is executing this particular function. So if I'm the one who is buying, or if it's someone else who is buying, the msg sender represents the address of that person. So it will move, because if you remember, when you sell, it was moving from the sender, the person who created who is setting this sale, who has to be the one who created this NFT, to the smart contract. Now it's moving from the smart contract to the new owner. So the linking is being done. So now they're the new owners. But in real sense, because we're using the subscription model, this won't be necessary, because we're not selling the NFT magazine. This is just a subscription. You're accessing it, but the seller is still the owner of it. So I will remove this, but use this whenever you're just creating basic NFTs. When you're creating a basic NFT where you're actually selling, and somebody in the normal NFTs, when somebody buys, they get the full ownership of that NFT that they've bought. So that's when you use this. But in our case, because it's a subscription model, we're not going to use this. But you can save this if you're actually creating the NFTs themselves. Sorry about that. So that was a small confusion. So what we're doing in the buy subscription, we're getting the price, making sure the buyer has set the correct price, and then we're sending this amount to the seller himself. And then now we're going to add we're going to add this person who has bought as part of the subscribers of this NFT. That means they'll be able to view, or they'll be able to see the magazine now. That's how we are setting it. So NFTs token ID dot subscribers. So if you're part of the subscribers squad, you'll be able to see the magazine of this particular token ID. So dot push msg dot sender. So you'll notice that in our subscription model, we are just changing these things up a little bit. But I hope it makes sense. So what we've done, we have just basically asked for the price from the buyer, the correct price. If they have sent the correct price, we transfer the money to the seller. right? So they have bought it. And for us to have a record that this person has bought, we're adding them as part of the subscribers squad, because that's those subscribers, the subscribers that are in that, when you're in that part of the subscribers variable, that means you have access to that specific magazine. This is the variable that we're going to use to give access to those people who have actually paid for the magazine subscription, and those who have not will not be in the subscribers flag. Great, so we are done with the buy subscription. That was very short and sweet. So let's head over to the next one. Okay, the next function will be, we want to get available subscriptions. These are the ones that on the front side or on the app, the first screen will actually load all available magazine subscriptions that are there. That means these are subscriptions that have already been placed on sale. So it's being set as accessible for everyone to buy and view. So for us to get all the subscriptions that are placed on sale, we first thing, let's create our comments. As dev, this function will fetch available NFTs on sale that will be displayed on the marketplace. Then lastly, we're going to return an array type called NFT. Let's see, NFT structure. Do you see this? So we're going to be returning like an array of objects. This object will contain each object will contain the NFT information of an NFT. So that's what we're going to do. So we're going to return an NFT struct array, an array of those objects, and then this will include list of NFTs with their metadata. Great. So let's create our function, call it get subscriptions, set it to public, and then set a returns. And we are returning, since we've already set it at the top, we are returning NFT struct, giving it a data location. Because we're just memory, meaning it says temporary, we're just assigning it temporarily. Next, we're going to now get, if you recall, we had a counter at the top that was saving the number of NFTs available for sale. So we're going to pick that count and say you want it 56 subscriptions is equals to NFTs available for sale dot current. Great. Next, we're going to now get the number of token IDs. So we're going to come here and get the number of 256 and get the number of NFTs total that we have. And to get all the NFTs that have been created in this smart contract, we use the counter token IDs dot current. Great. So there's a reason we are doing this. So we're expecting to return this type NFT struct array. So we're going to define it first, define one internally that we're going to use. So we're going to give it memory data location and call it NFT subscriptions, and we're initializing it and giving it a size. The size we're expecting is the subscription, so it's a dynamic array. Next, we're going now to do a simple for loop where we are checking with NFT count. That means the total number of tokens. We're going to go through, use the NFT count to actually loop through every NFT and check, is it on sale? If it's on sale, we add it on our NFT subscription struct and create an array out of that. So how to do that is we say for uint 256i is equals to 1 NFT count. So using the NFT count, so it should be less than I plus the basic for loop. So we're doing a check here. So if NFTs of I, remember, okay, the token IDs, if to make it simply, if you remember, as we're creating these token IDs are like starting from 1 2 3 4 5 6 7 8 9 10. So we're using I as a starter because our first NFT should be holding the token ID 1. So we're looping through. So if NFTs with the token ID of I dot owner, because we're checking where the in terms of ownership, we want to check where the owner is equals to the address of this, the instance of this contract. Because if the owner is equals to the address of the instance of this contract, that means it's on sale. So that's how we're doing it. Is equals to address this. If that's the case, we pick this and we pass the token ID is equals to, we pick the object of this. Does it make sense? For loop, sorry. So what we're doing is we're doing a for loop of all token IDs and checking the ownership of each. If the ownership is address this, meaning that the owner is the instance of this smart contract, that means it has been placed on sale. And that's what we need to display on the marketplace, those NFTs that have been placed on sale. So if that's the case, we are designing an array of NFT struct. This is a custom object that we have created within the smart contract. So we're defining it, giving it a key of that token ID, and which holds the value of the object of that specific NFT of that specific token ID, right? So once we have that, we come over here and do a return of NFT subscriptions. Basically, that's what we have done. I think, yeah, okay. So function state mutability can be restricted. So to avoid any mutability, we set it to view and we are done. So we're basically, with this, we should be able to get all those NFTs that are on sale, and then on the front end we just display them because they will come with the image, they will come with the title, they will come with the description, and also they will come with the price, all that shebang, and also come with the subscribers and all that. So we'll be able to display it in the front end easily. So let's head over to the next function. The next function is we want to create a function where we can fetch. If you're familiar with the NFT world and interacted with maybe like some of the interfaces, you may have heard of collectibles. So we want to fetch NFT magazines that a specific user has already subscribed to, right? In normal NFT of images, it will be a specific fetch NFTs that a user has bought, or that's why it's called collectibles, that a user has collected. So in our case, a user has subscribed. So to do that, we're going to create our NatSpec comment and set it as, this is a function that fetches NFT magazines that a specific user is already subscribed to. Great. And then we'll return our NFT struct again. I hope you're seeing how certain variables that we have created, how they're being used within the smart contract, which represents a list of NFTs collected by a user with the metadata. Great. So now let's create our function. Call it get collectibles. Set it to public. Returns NFT array and give it a temporary location. Great. Now let's start. First, we were going to get all the number of all tokens, all NFTs that we have created. To do that, we just define a new variable called NFT count, as we did in the previous function, and took the token IDs and picked the current number by. That's how you get the total number, by just picking the current, using the current function. And then next thing, we're going to define a variable just the way we did at the top here. So we're going to say NFT struct memory and call it NFT subscriptions. Next, we're going now to use our for loop. So let's first create our for loop. So it will be uint to 56 I is less than NFT count. I increment. So inside here, we're going to pick, so it will be a little not too complex. So what we're doing is we're going through each and every token ID, right? We're looping through. So we're picking every token ID. We're going to our NFT, our mapping, and checking the subscribers dot length. So we're using, once we get the length, we're not going to go to that specific NFT let me show you how we're going to do it. So we're going to set another variable called subscribers, right? So we'll get that from our mapping, and then set it its token ID, so that you can go and pick the subscribers dot length of each. So the reason why we want these subscribers is because that's where we have stored people who have actually subscribed to a specific magazine. So we want to check through this person who has actually executed this function, whether they are within looping through each and every NF mapping to check if they are part of this list of subscribers in any of the tokens. Whichever that they are in, we are adding it to the NFT subscription. Basically, that's what we're doing. So we'll do another for loop. Okay, so it will be uint to 56 j is equals to 0. So we're creating another for loop within the other for loop, and then we're getting j is less than subscribers, because we're looping through now the subscribers array, and then we increment it. So inside here, we'll be checking if NFTs of this specific the token ID dot subscribers. Remember, the subscribers is an array. We're also checking on it in terms of j is equal. So we're looping through we're looping through the mapping. Then inside the mapping, the subscribers is an array. So we're looping also in that array to check if we can find the msg.sender, this person who is actually executing this function. And if we do, we add it, we push this, set this token ID, we set this I is equals to NFTs I. So what we have done is we have made sure that there's this uint is equals to 1. Wow. Uint is equals to 1. I is less than NFT count. I plus plus. So we've gone into the mapping itself, and now we've picked the length of the subscribers so that we can now loop through the subscribers as well as we check through the msg.sender. We want to find this person, and if we actually find them, that means they have access to this specific token I. And then yeah, basically that's what it means. So once we are done with that, we'll return NFT subscriptions. So we'll just come here and return that, and we'll add the view to manage the mutability, and we're done. So with this, we should be able to get the NFTs that this specific person has subscribed to, and display it mostly on the profile page. This is a function that we're going to use. So let's head over to the next function. Great. So we have got the collectibles of a specific user, but we also want to get the NFTs that a specific user has created. So to do that, we are going to come here and add our not spec comments. So what do we need? We need a function that fetches NFT magazines that a specific user has created, and then we will return the NFT struct, the array, which will be a list of NFTs created by a user with the metadata. Great. So create our function, get NFTs, set it to public so that we can interact with it, define our returns, NFT struct, memory, set it temporarily, and then we can add our view as well. Then inside here, we're going to get the total token IDs, NFT count is equals to token IDs dot current. Next, we're going to define our struct variable and call it NFT subscriptions. Then we're going to do a for loop. We're checking through, but it won't be as complicated as the previous one. So we'll do a for u into 56 I is equals to 1. I is less than NFT count. I increment. Wow. Great. Then inside here, what we're going to do, we're just going to do an if NFTs I, because you see when the dot seller is equals to msg.sender. If NFTs I, the token ID dot seller is equals to this, we're going to add I is equals to NFTs I simply. And the reason why this is easier is because the seller is just it's a string. Unlike the subscribers here, it was holding an array of addresses. So once that is done, we just come here and do our return. And we're done. So that will also be in a section somewhere in our profile where you, if I am the one who is using the app, I'll be able to see the NFTs that I have created, and there'll be another tab now that represents the previous function that shows the collectibles of the NFT magazines that I have subscribed to. So that's done. So let's do the next function. Let's focus on creating another function which fetches information or details of a specific NFT magazine. So we'll create our comments at dev fetches details of a particular NFT magazine subscription, and then we will return our parameters will be the token ID, which refers to the token ID of the NFT magazine. And lastly, let's set the return to NFT struct, which will contain the data of the NFT, or in short, NFT data of the specific token ID. So we'll create our function, give it the name get individual NFT. We'll set it to public, and it will return NFT struct. Set it to memory, and then we'll get in here and also pass the token ID. Great. So inside here we're going to just, it's one line of code where we'll just return NFTs of this token ID, and we are done. Let's add the view modifier, and we're good to go. So this is the only thing that we need to add. Let's focus on the next function. Great. So the next functions that we're going to focus on will revolve around user profile management. So to start with, we're going to create a function that partly represents user registration or like user onboarding. So we're going to just create a notice here saying that this represents user onboarding, sorry. So we get to like have records or data of the users that are actually interacting with the NFT marketplace. And if on the front end, we'll have a profile section, so we'll be able to manage certain attributes like following, the number of the following that they have, the followers that they have, and also like the number of NFTs where necessary. So to do that, we're going to add, because we're not really doing a whole like a login feature on the front end side. What we're going to do, we're going to save the MSG sender. That will be the unique ID or the unique factor of each and every profile. So to do that, let's just add a comment for the dev that says adds msg.sender as the profile. Just the way in a normal login we have username, password, or Gmail. Here we'll just use msg.sender to create the uniqueness for every user. So let's create our function. We can create our function and call it add profile, and then set it as public. And then we're going to come here and create another counter, because it's good to know the number of users that we have in our small smart contract. So we'll just create counters dot counter private, because we're just going to use it within the smart contract, and call it user IDs. Then we head over down and come here and set user IDs dot increment, because every counter starts with 0. So we want to start with 1, and then we just pick the new the current user ID. So it's user IDs dot current, and then we're going to create a struct, or we're going to create a mapping called profiles, just the way we did on NFTs. We also want to manage for profiles as well. So we'll give it int 256, which will be that user ID, and then it will hold profile struct, which will also create at the top. We expect an error right now because there's no such thing as that. Private, and call it profiles. Then we head over at the top here and define our profile struct. So our profile struct will look something like this. So profile struct, it will hold the address of this person, of the person who is actually interacting with the system. Then it will hold the followers in form of an data type, an array of data type address. So this will represent the followers, and then we'll have the following. Great. So with that done, and then we have this, we head over to our code and come here and use the profiles mapping. State it new user ID dot self is equals to msg.sender. So we have created the first user. When the first this is the way we're going to create our first user record, and then we are going to return we didn't add this on the comment. So right now the self will be the msg.sender, but the following and the followers will be 0. So for us to, let's set the return. So for the return, we are returning the user ID and the balance of this of msg.sender. Great. So we'll come over here and return. There are very many ways of creating a return statement in our function. So the one I'm doing will be one of them. So we say returns uint.
The long ton, also known as the imperial ton or displacement ton, is the name for the unit called the ton in the Avogadro system of weight.
Int 256 user ID and uint 256 balance. So we'll come in and take user ID is equals to new user ID, and balance is equals to msg.sender dot sender dot balance, and we're done. And this variables like msg.sender, msg.sender.balance, remember they are global variables. We're not defining them or creating them. They're actually global variables that exist. So let's focus on the next function that revolves around the profile. Great, so let's create the next function that performs the follow profile, meaning that if you want to follow a specific profile in the NFT marketplace, that follow action event, we want to work on it so that when somebody wants to follow the profile, it increments the follow tag on that profile, and also it increments the following tag of the person who wants to follow the profile, and increments the follower tag or the followers tag on that profile that they actually want to follow. So let's just try it. First things first, at dev. So the idea is to increment the following tag of the profile performing the action, and the follower tag of the profile that user wants to follow. Next, we are going to pass the param. The param that we're going to pass is account, which represents the account the user wants to follow. So let's create our function follow profile that will hold the argument account, set it to public because we'll need to interact with it. And then now first we'll get the number of users, or the number of users in our profile mapping. To do that, we just create a variable uint256 total count is equals to user IDs dot current. Next, we are going to do a for loop. So for uint256 I is equals to 1, I is less than total count, I increment. So if our mapping profiles dot self is equals to the person who is actually executing this request, let's update their following by pushing the new account. Great. So this person will have, when they decide to follow, in their following they will have incremented by 1. And then if profiles I.self is equals to account, we go to that person's account as well, but now we'll go to the followers and push the person who is executing the request. msg.sender payable Great. So basically that's what we are doing. So the follow profile will just be updating the following and the follower. So let's create the next one, which is unfollow. So for unfollow, it's the same thing here. What we're going to do is we're going to decrement the following tag of the profile performing the action, and the follower tag of the profile that the user wants to unfollow. Great. So our param will be an account, which represents the account the user wants to unfollow. So let's create our function unfollow profile with the argument account. Set it to public so that we can access it. Then inside here we're going to get the user IDs. Total count is equals to user IDs dot current. Great. Then we're going to do a for loop just like the previous one. 256i is equals to 1. I is less than total count. Increment. So inside here we're going to do two things that will be quite large. So I'm going to divide them into two functions where we're going to remove following tag and we're going to remove follower. So we'll have function remove following private, and then we're going to have another function remove follower private because we're just using it within a smart contract. So there we have it. So what we're going to pass here, we're going to pass the profiles. We're getting the address of this for this specific, for where key is equals to I. Then we get the profiles, we get the followers, and then we pass also this account. So if we come here, we'll have address, owner, then we'll have address, set it in a temporary location and get the followers, and then we'll have the address, account, the one that we want to unfollow. And then here we're also going to have the same thing but now following. Okay, so we'll have the profiles I.self, and then we're going to have the profiles I.following, and then we're going to have msg.sender. So if we come here, we're going to pass address owner, following, and lastly address account. Great. So when we're doing the for loop, it will be passing through these two functions. So now let's work on these two functions. Inside the remove following, what we're going to do, we're going to say if owner is equals to the account address memory, we're creating a variable of type address. We get the current following is equals to of type array. We get followers Okay, and then we're going to do a for loop. For we create into 56j is equals to 1. Current following. So if current following j is equals to payable msg.sender, delete current following j. So we're decrementing, we're removing it. Sorry, dot length. Whoa, because this is an array. Correct. So we'll come here and set this to view. And then let's focus on the next one. The last one, this other one is almost the same thing. If other is equals to account address current followers, the terminologies may confuse you, followers, following, but it's actually correct. So for you into 56, j is equals to 0, j is less than current followers dot length increment, and then inside we're going now to check if is equals to the account delete. So we're decrementing that. Great. So we're removing following. This person doesn't want to follow this person anymore, so you want to unfollow. So we're removing the decrementing your following by removing that person from your following list, and then also on their side, on that person's side, the follower list, we're removing you, the user who wants to unfollow. So that's the idea. Owner account. Great. And view. Okay, so with that done, we already have created 3 functions that revolve actually there are 1, 2, 3, 4, 5 functions that revolve around the profile. So next thing, we're just going to do like a few more functions that revolve around now a specific NFT, and yeah, let's look at that. Now let's look into 2 more functions that revolve around the NFT, the NFT magazine itself. Now we've left the profile section, then we now head over to the events and functions that revolve around the interface of ERC5643. So to do that, we want to do 2 things. We want to create a like function and a like function, right? And also an unlike function that can manage that. So in our front end, we have set a way that you can actually set a like, or yes, you can set a like on a specific NFT. It's a way of generating some data, knowing that these are your favorites. You can even add a pay screen for favorites, where you can be able to see your favorites first. So to do that, to be very short and sweet, so let's create that one at spec comment. So at dev increments number of likes. If you remember, we have this tag in one of our strat, in our NFT strat. So for our NFT magazine, by 1, and then we'll pass the param, which will be the token ID, which refers to the token ID of the NFT magazine. And lastly, we'll do a return. We could do a return or not. Let's skip that first. So let's create our function which like a subscription, and then we pass the token ID, set it as public so that we get to interact with it. And then inside here, what we're going to do is just say NFTs, pass the token ID dot likes is plus is equals to 1. That's all you have to do. Great. Now let's do unlike function. You can just add this comments and just remove increment to decrement. And then just create the same type of function, unlike. And then we'll come here and do a decrement by 1. And we are done. In this case, we don't really need to return anything. So simply this is the last, I think, function that we are designing. Let's see. Yeah, our code is formatted. So let's now focus on the functions and the events that are revolve around 5643. Great. So we have created a number of functions in our NFT marketplace contract, which I hope it has made sense along the way. Now we're going to focus on the ERC5643, which is an extension of the ERC721. And for us to be able to use the functions or the interface of that standard, we are going to create another contract and call it subscription model. And inside here, I'm not going to write code one by one because already there's a documentation from the EIP that displays or provides the implementation part. So all I'm going to do is just copy it, and then we're going to review it together. Great. So this is the whole code. This is the implementation that you get from the documentation. So we can go through it on it, and also be assured that the link to the Git repository will be down below. So just to confirm or counter check for yourself. So first thing we're in the contract, there's a state variable called expirations that handles expirations. And then we have an event called subscription update. So whenever there's an update on the subscription, this event is emitted. Next, now this is the ones that the next functions are the ones that we'll interact with a lot. For example, the renew subscription, we need to, so what will happen is that when we create the NFT as a user, or how the DApp or the Flutter DApp will work is that a user creates an NFT, and then when they place it on sale or like sell the subscription and make it accessible, they sell it for a certain duration of time. And when that duration is over, they should be able to have the option either to renew the subscription, and also if the duration is not over, they also have the option to cancel the subscription. Okay. So This renew subscription, what it expects is a token ID and the duration. So this function manages all that. If you need to renew, so this expiration is a state variable that handles the states in terms of expirations for every token ID, the ones that we've been creating. So it comes and checks if this token ID does no expiration, create one by using the block.timestamp plus the duration that we have passed. Block.timestamp is a global variable, don't worry about it. Now that will be the new expiration. Else, if there is already an expiration duration set for this token ID, just take it and then add plus the duration that has been passed. So you increase it, you add it to the current expiration. So you end up setting this expiration of this token ID to the new expiration that you have set. So that's how the renew subscription works. And then you just emit the event so that it's a transaction log somewhere in the blockchain. The next one is the cancel subscription, where you pass the token ID, and all it does is just deletes the token ID from the expirations. So there's no subscription, in short. Okay. Another one is if you want to know when a specific token ID will expire or expires at, it will return for you the expiration date the expiration date of the subscription. This is what it does. It just reads as what we have been doing in the other types of mappings like NFTs. You just read using the key, and that's that. Then is renewable. You can either set a specific NFT magazine to be renewable or not, but I have set mine to be true, or that's how it's also in the implementation, but it makes sense here to set it as true for now, unless there's a use case where we want to allow certain NFT magazines to not be renewable. Okay, so basically these are the functions and the events that revolve around the subscription model. So what we want to do is, now that we have this, we want to inherit to the NFT marketplace. This is the beauty of inheritance. You don't have to rewrite things over and over again. So what I'm going to do is just pick this and add it over here together with the ERC721 URI storage, and we are done. So the essence of inheriting is that this NFT marketplace not only has the functions that we have created this far, but also has inherited the functions that are in this contract. And if you have interacted with contracts before, you'll notice that there's a limit of the lines of codes you can actually create. So it's also good to actually break down your contracts and you can have multiple contracts in one file. So I hope this makes sense. The documentation and the comments were explained very well, and I hope I've also given you an enlightenment on it. So the subscription model focuses mainly on these additional functions that are not in the ERC 721. I hope the session has been has been very educative, and you've learned a lot. And we have actually finished the smart contract development lesson stage, and it doesn't mean that whenever we have any changes that we need to do, we'll always come back and implement it or change anything that we need to do as we develop also the front end side. So but all in all, this is the contract, this is how it looks, these are all the functions that we'll interact with. We've been able to also interact with the other functions that represent the ERC 5643. I hope it has been enlightening and interesting. So let's stop here, and I'll see you on the next lesson.